off a cool little Elixir pooling library called PoolBoy. Actually, I should say Erlang, because that's what it is.
Do you have Flux on your...
Yeah, you want me to turn it off?
Yeah.
Yeah.
Just disable it.
Yeah, yeah. I'll pull this up on the side. So yeah, it's a cool little Erlang pooling library. I think probably everybody in this room has a concept of what pooling is, but just to cover my bases, it's a strategy for basically keeping around a series of resources that you can check out and check back in. So this can be processes, objects, database connections, doesn't really matter. Usually have some kind of client to check those out, run some function with it, and then check it back into the pool. So rather than having to create these things on the fly, you can just kind of have them sitting on standby, so you can kind of optimize your process in that way. So I just want to show a quick example using PoolBoy. I wrote this little demo app called Hive, and so basically what it does is it just initializes a pool of bees and then makes the bees go get honey. So first step is always to obviously add this to your make steps PoolBoy and then make steps.get, so you can actually use it. And then yeah, I have these three main modules: Hive, Beehive, and Bee. So I'll start with my application module here. So basically, the main thing to talk about right here is just that we're initializing this supervisor in our children, and the supervisor is this Hive Beehive, and that is what's going to supervise our pool. So if you kind of think about the metaphor, the beehive is kind of a pool of bees. You know, it kind of makes sense in nature as in computer science land. So then in Beehive, I have this pretty vanilla start link function. So we're going to say that we're starting up the Hive supervisor there, and then we're going to start link. And if we bump down to this init function, we see that we're initializing these Hive options, or these are the pool options. We've got a name, we've got our worker module right here, which is B, and that's just going to say this is the kind of process that's going to comprise our pool. We have a size, so when we initialize the pool, we're going to say we want 20 bees. And then in the event during our application lifecycle that we have all 20 checked out and we need to use another, we're going to allow ourselves to check out, to create on the fly, at a cost, obviously, because you're creating it dynamically, create on the fly 10 additional bees. But once you hit 30, we're using our 30 bees. We're not creating any more bees. And then actually I'm going to take this strategy out real quick so I can come back to that. And then we're going to instantiate our pool here as a child and then supervise it. And so that's pretty much how we're going to set up the pool. I'll show the B module as well, just so we have an idea of what's going on. So each B is its own gen server. So again, we have this start link, and then I'm going to print out that we have B with a B PID standing by, and then we're going to initialize each bees with no honey, which is sad. Then let me see. I think that's all the setups, and now I'll show you how it actually works. So first thing we might want to do is just be able to send one bee out to go get honey. So the way we're going to do that, if I spin up the app, and you can see when I spin up the app, we have 20 bees standing by, and you can see these are all distinct processes by their distinct PIDs. So then I'll pull up Beehive. I'm going to call this, I'm going to alias it first, so, and I'm going to call beehive.getHoney, and I'm going to get an error, or gather honey, excuse me.
You got the font on both?
Yeah, for sure. Boom. So I'm going to call beegatherhoney, and we see one of our bees went and got some honey. Returned us our honey map, and then re-instantiated its state as just the state that it started with, which was no honey. So pretty simple. But the way that that's working actually is PoolBoy in the background is conducting a transaction with our pool. So actually, I think it'd be kind of cool to pull up the actual PoolBoy code and show what's going on here in this Erlang. So if you drop down to transaction, so you can see right here, we're going to check out. Our worker. So we're going to check out our bee. Then we're going to apply the supplied function using basically using the PID of the bee that we checked out, which is why in B on our gather honey function, which gets called by Beehive, we're passing in this PID. And then what I'm doing is using GenServe to call that PID with the gather ID atom, and that's what's calling the actual handle call function. But so that, I guess that was the part that really tripped me up the most when I was first learning how this works, is conducting this transaction. It passes in, that's going to pass in the PID of the B that gets checked out into the supplied function. So this could also be written as this right here. This is basically the same thing. Conducting PoolBoy transaction, passing in a PID, and then b.gatherHoney with that PID. That's kind of how that works. It's kind of cool. And then you can see after we're done, we check it back into the pool, and he's ready to go next time we need him. So that's how we do that one time. I wanted to show one more kind of cool thing, which is how we make all of our 20 Bs work in parallel, which is kind of cool. So let's see. I've got this function right here called buzz, which spawns up however many honeys I want to gather. It will keep sending bees out until we get that many honeys. That's in, and then when we have all our bees spawned, we're gonna get this little all spawned atom. So if I call hive.buzz and I call 10, we see all these distinct bees going out to get some honey, and then telling us that they got some honey, etc., and we see they're all spawned, and we're done. One more thing, I guess, is if I were to do this with like 100, we're gonna see first of all a lot more bees. Actually, we're going to see a lot more bees going out, but we're also going to see ourselves instantiating some new bees because all of our bees were checked out. So like I showed you with the hive options, where we said the max overflow is 10, we shouldn't see more than 10 new bees. So if I go through here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, boom, that's it. 10 new bees. We're doing all our work with 30 bees, and that's basically how it works. Any questions?
So you pulled out the strategy.
Yeah, right. That's a good one. So if I just call that beehive.gatherHoney, and I do that, yeah, alias. Yeah, and then beehive.gatherHoney, we're going to see the same bee going to get that honey every time. Because what's going on there is a LIFO strategy, last in, first out. So we can actually change the strategy. I learned this just looking in the PoolBoy Erlang, so we can actually pass in FIFO and recompile. And I believe, if I'm not mistaken, we should see a new bee every time. So, for whatever that might be worth, if you want to change your strategy to a queue instead of a stack or a stack instead of a queue, you're welcome to do that.
Do you know if that has any performance implications? Why a person might want to.
So let's see. So I was kind of trying to dig into this a little earlier today. Yeah, there you go. So this is the difference. We're just putting it for LIFO. We're just putting the PID that we're checking back into the head. Whereas with FIFO, we're going to append it to the end. So that's, I don't know if I don't really have any real comments on the performance implications because I don't really know, but I know that that's how that's working right there.
I think isn't appending the funnel is cheaper?
Yeah, I think it's It's a linked list, so it would be, unless it's a doubly linked list, then it's fine.
So LIFO is probably technically more performant.
If it's the default, it's probably.
Yeah.
So it'll just keep blocking if you queue more than 30 in this case?
Well, right, so then it's just going to have to wait for another one to come back, basically. So I guess the trade-off there is if you open up too many connections on your database, you'll start seeing timeouts, or open too many processes in the pool. I guess you could potentially start timing out. But yeah, I've usually for this kind of thing, I think 2010 is kind of a reasonable default. I think I've done this in the context of having a Redis connection where we need to do a whole lot of Redis lookups, so we want to retain a bunch of connections in the pool, and I think we use something like 2010, 25.
So this is being used by Cowboy, right?
I'm not sure.
Or it's being used in Phoenix, I thought, at least.
I don't think it's default Phoenix because I had to add this myself and get it.
Well, I think my understanding was that Ecto used it to manage database.
Oh yeah, I think you're right about that actually. Yeah, I think so. You can check.
I just looked up PoolBoy Phoenix and I found ads for pool cleaners in Phoenix, Arizona.
Yeah, Phoenix is the worst.
Not a good term.
I mean, so it's in
All
there. It's
work
in
is your fun.
it's in the mixed log. It's in their mixed log. I would think so. I think I've seen that somewhere too. But yeah.
Yeah, I think Phoenix Ecto is kind of like doesn't do much compared to just Ecto.
Oh yeah, that may be different.